unfortunately have a little bit of audio as part of my presentation that may not work. We'll give it a crack. What we're going to get is probably a lot of reverb. So without further ado, my name is Alex Heggart. I am a Solutions Architect at AWS. Thank you all for being here, for braving the weather. It's fantastic to see such a great turnout. Especially with all the challenges of getting together these days. A little bit about myself. I started life as a software engineer, working for a defence contractor, actually working on trains. So when I get to visit Sydney, there's still some trains running over there with some of my software on, which is good to see. It still lasted. Got to work on some military vehicles, which is cool. And then took a little bit of a twist and ended up a life as a data engineer for a brief, probably actually not a brief stint, but an old school data engineer, one that was working in the ETL days, working with traditional ETL tooling and an Oracle data warehouse. So all the cool stuff that people are doing these days, and I'm looking forward to the next demo for Dvt on Azure, which looks really fantastic, is a little bit beyond me. So I'm going to go to fundamentals. I think they're important, and I think as a data engineer, it's really important that we kind of understand some of the concepts of how we look after people's data and encrypt them. And while this specifically is going to be talking about S3 and things on AWS, keep in mind that the principles that I'm talking about and the mechanisms are absolutely applicable to all of the services, solutions, cloud providers, on-premise tooling that you use. So I'm going to give this a go, and I'm going to try with sound, and we're going to see if it goes horribly wrong. So I'm going to mute that. I'm going to say, so I've got a text file that I've just happened to find on my laptop. And, if someone happens to come across that, I've used Amazon Polly, which is a text-to-speech service that we offer. And I've put that in there, and we're just going to hear the results.
Hi. My bank account number is 12345.
Stop that. No one wants to hear my bank account PIN either. That would be very, very bad. So what I'm going to do is I'm going to encrypt that, and someone's cut them off.
Do you want to just try to turn off from here?
Yep. There we go. Beautiful. So I will attempt now just to play that encrypted file. Well, it's actually, that definitely hasn't worked. What it's meant to, Polly does an amazing job of, try again. Yes. So what I wanted to highlight was Polly does an amazing job of reading out a lot of very, very complicated characters, including a few slashes in there. So completely dead.
This one's
hey.
as well.
Thanks. Completely dead. So I'm going to do a live demo later. So this is going to be even more interesting. So just wait for that one. But unfortunately, if anyone wants to, they can come past later, and I can try and we can listen to Polly read out this wonderful encrypted file. So let's move on to the fun stuff, or the fundamental stuff. So encryption support, and this is stuff we're going to find everywhere. We've got two forms: encryption in transit and encryption at rest. So encryption in transit is HTTPS or HTTP. With transport layer security on top of it. So it's what secures your bank account details when you're logging into your website. And pretty much there shouldn't be any website out there these days that's not using it. So Won't go into depth around that. In terms of encryption at rest, and this is why I want to talk to you, there's 4 different kinds that we can do. So we've got SSE S3, which is Amazon S3 managed keys. That's what I call the freebie. So that's there just to make things encrypted. We own the keys and manage that all for you, and there is no cost to that. We then got SSE KMS, where you can use the key management service. There is a cost to generating data keys and getting those keys. And we've also got SSEC, which is customer provided keys, where we'll do all the compute, but you provide your own keys. I'm going to go into these in a little bit more detail later. The other one that we do have is client-side encryption. So you can manage that all yourself. You can also use stuff like the AWS Encryption SDK, which you can integrate with pretty much any programming languages that you choose, and we'll provide an open source implementation for encryption that you can use. So I just want to go into very briefly some data protection terms. The first one is envelope encryption. I think this is probably what's most misunderstood when I speak to people around the encryption that does go on. So it's a practice of encrypting plain text data. So that was that text file that I had that happened to have my bank account details in it with a data key, and then encrypting that data key under a centralized key, in this case, a KMS key. So it's called envelope encryption. It's wrapping a data key, which is what you use to actually encrypt or decrypt your data, with another centralized key that you can manage access to. And that's typically locked away pretty securely. And with KMS, you can manage with resource policies, very fine-grained who actually has access to that. So we've got our KMS key here. So that protects your data keys. It's in AWS, it's uniquely identified by a resource name, and it sits at the top of your hierarchy. And then we've got our data keys. So the data key is what we use to actually encrypt the plain text data. And so you can go to KMS and you can request a data key, and it will give it to you, and then you can use that to do locally, or in the case within the S3 service, your encryption and decryption. And then we have our plain text data, and so that was that text file that had my details in it. So this is any information that you want to protect. So in the case, it's any of the files that you have stored in S3, but it can be used in lots of other situations. And then we have our Cipher Text. So this is the encrypted version that unfortunately we weren't able to get Polly to read out, but it's not very human readable at all, which is by design. So for SSE S3, we have the S3 managed keys, where each object is encrypted with a unique key. As an additional safeguard, it encrypts the key itself with a root key that it regularly rotates. S3 server-side encryption uses AES 256, which is pretty much industry standard for protecting your data. And there's no additional fees for using server-side encryption with Amazon S3 managed keys. So really, this is, I guess, the default stance that you should have for encrypting your data. There's no performance penalty for enabling this form of encryption. There's no additional pricing for using it or anything like that. And so now I'm just going to talk about the SSE KMS, and this is one that I see is very commonly misunderstood when we get into the kind of envelope encryption. And so this is using AWS Key Management Service. So we're going to have a plain text data file that is written to an S3 bucket. So someone makes a put request. In that put request, they also have a header that indicates that we would like to use SSE KMS encryption. And so S3 goes off to the key management service and says, using the provided resource name, can you please generate me a data key? So the important thing is here is it's asking for a data key, not for the actual copy of the key from AWS KMS. KMS then returns to S3 an encrypted data encryption key and a plain text data encryption key. So that top one is part of that envelope encryption. And so the data key that has been generated is wrapped up within the envelope of the key in KMS. And then the data encryption key is provided in plain text as well, because S3 needs to actually do some encryption for it. And so what S3 does is it then takes that plain text data encryption key, loads it into memory, encrypts the data, the plain text file that has been supplied, and outputs some encrypted data and an encrypted data. Outputs some encrypted data. And when it's done that encryption operation, it throws away out of memory as soon as possible that plain text data encryption key, because that's something that could be used to decrypt your data. So that's thrown away, and all that's left is your encrypted data and your encrypted data encryption key. And that's what gets written to your S3 bucket, and it stores the encrypted data encryption key next to it. And so if we look at decryption here, then someone makes a GET request for that same file. S3 goes to the bucket, pulls out that encrypted data as well as the metadata of the data encryption key. And then it asks the KMS service to decrypt the encrypted data encryption key. So because it's been wrapped up in that envelope, S3 can't do anything with it yet. And so it goes off to the key management service and makes a decrypt call and says, can you please extract me out the data encryption key that I need to decrypt that text. It then gets returned a plain text data encryption key to S3. It can then apply that to the encrypted data, and then we've got our plain text file again, and that is what is returned out to the client. So historically, in this approach, and I have seen this, at scale, this mechanism for accessing constantly going to KMS for every single request to write lots and lots of little files can have a big performance impact and price impact. So we do have a option with bucket keys that can deliver a massive improvement, and I've worked with a customer that has implemented this and made significant changes to their KMS costs and their performance. So essentially what it is an intermediate key. So rather than using the same or rotating that data key every single file, it will keep a intermediate key for a period of time and then rotate that regularly. And so if you're doing lots of little transactions at scale, really quickly, that has a big impact on the performance that we see. And so the last form of encryption that I wanted to talk about in terms of server side is customer provided keys. And this is an option where you can provide your AES 256 key as part of your request to S3. S3 then does all the heavy liftings. It does either the encryption or decryption, and when it writes, to the disks, and when you access your objects. And again, there's no charges for doing this. So the advantage is that rather than using the Amazon managed keys that rotate regularly, you're able to manage that encryption key yourself, hold on to it, and just pass it through a request. So a few caveats, don't do this over HTTP, because then you've just given out your encryption key to whoever happened to be able to sniff that packet, which is not great. If you do that, S3 will actually reject that request and essentially tell you, please throw away that data key because it wasn't secure. The other thing is, you do have to then manage protection of that key, distribution, and keeping it safe, which, depending on maturity, can be harder to manage than using the default encryption. So if we want to encrypt, pretty much everything, we want to look after our customers' data. How do we do that? How do we kind of enforce, encryption? So we do have the ability to set a default encryption for S3 buckets. So you set that up on your bucket, automatically encrypts all new objects, allows for kind of simplified compliance in the manner that you can get a default level of encryption. For example, just SSE S3, though you can also do it with SSE KMS. So this is great. You can set a default level of encryption. If you do want to write objects which have a different type of level, so for example, you want to use the KMS encryption, then you can do that yourself and overwrite the kind of bucket defaults that are going to be applied. So the last one that I wanted to talk about is client-side encryption. So you can encrypt your data locally prior to passing to the Amazon S3 service. The S3 service receives your encrypted data, so it doesn't play a role in encrypting or decrypting it, and this can be completely self-managed. You can also use KMS and the encryption SDK to more easily implement encryption if you so want to. Obviously, this is something you have to manage yourself. So advantages is ultimate control, right? So you can do whatever whatever you want. You can rotate keys as often or as little as you want. They're all managed yourself, but then you have to apply the kind of level of governance and management of that as well. So advantages and disadvantages. One thing I did just want to mention when it comes to the SSE server-side encryption KMS that we saw previously, the reason a lot of people do want to go to that is typically they have, a directive to own the encryption keys that are used for managing sensitive data, right? What I'm trying to stress is that it shouldn't be a one-size-fits-all kind of approach, and we do need to think about things like encryption as you would potentially with writing to different types of data stores. Use the right data store for the right kind of approach of what you're trying to achieve. In this, use the right type of encryption. So encrypt everything for sure. Use the cheap, free SSE S3 that you can turn on by default, which we all manage for you. But there, when you've got potentially PII, commercially sensitive information that you want to hold on to, hold the keys for that, then you can go to something like using KMS, and you can get some really powerful management of those actual KMS keys. So, when to encrypt? Well, I think I already spoke about that. Always encrypt, but there are definitely trade-offs, and this is going to be live demo time, so we're about to see how fantastic this goes. So bear with me. Hopefully slightly better than the other one. So I'm just going to jump into EC2 instance that I have provisioned previously. Let's jump into my home directory. And now what I'm going to attempt to do is use my mouse while holding a microphone, which is going to be very exciting. So what I've got is about 1,000 files I've just generated. They're all quite small, so it's a bit of a contrived. I would say it's not actually contrived test. But if you're working with bigger files, the overhead of encrypting and decrypting, talking to KMS is not going to be obvious. With lots of little files, it probably comes along a little bit more. So I'm just going to take all of these files and push them up into a S3 bucket. So there should be 1,000 files in there. And what we should see is down the very bottom there, we're getting in the range of about 2.8 megabytes a second in terms of transfer speed. So this is just unencrypted at rest. It's going straight into my bucket. I've got nothing set on it. So now I'm going to very quickly jump across and say, can I please have some SSE KMS. So what this is going to do, and unfortunately it's kind of just hidden by the, let's see, let's get creative. Surely I can move this across. What do you reckon? Hey, okay. Awesome. So down, oh yes, the hide button. Thank you, Jonathan. He's a wizard. There we go. That's exactly what we wanted. So I'm going to do pretty much the same copy here, but what I've done is I've specified I want KMS encryption, and I've specified my KMS key, the resource name that I want to use. What I really quickly wanted to jump into, this is my customer managed key. This is the KMS key that I've requested. And we've got a key policy on this. So I said when you use KMS, you can get resource policies that are quite powerful. I can control very precisely who has access to this key. So including people that actually generate the data and can encrypt data, I can say, well, you can't actually decrypt it, and you can pass that control to someone else. In this particular case, I've assigned a IAM role to the EC2 instance that I'm running. So that's my virtual machine. And I've given it the KMS generate data key. So it's got the ability to go off and request that data key, which is what we need to encrypt the data. And then we've got the KMS decrypt functionality as well, that action. That API call allows us to then pass the encrypted data key to KMS, get it to decrypt it, we take that and we get a plain text file out the other side. So there is a little bit of overhead on that. And if we go back and execute this now, what we should see is we've kind of tanked down the bottom here, down to about 2.1, 2.2 megabytes a second. So we've probably lost 20, 30% off the top in terms of that overhead for all of those files. Now, I am going to go across and I'm going to go back and just run again. And what we've done is we've kind of gone back to our original speed. So I probably should pause before I press the enter there, but that command was essentially just saying, give me that free server-side encryption. So just do the default stuff, no performance overhead that we've seen there. Your data is encrypted. That should be your default. And then what I just quickly wanted to demonstrate was I've actually set up this bucket key functionality. And so this is where rather than going back to KMS every single time, having to get a new data key, it's going to cache that for a little bit. So there's still going to be some performance overhead there. But what we should see is down there, it's got to probably around 2.5, 2.6 megabytes a second. So sitting somewhere in the middle between, full-on encryption, rotating that data key every single time for every single file, to a little bit of caching that's going on, getting some of that performance back. So Hopefully that kind of explained, that some of the trade-offs that you are going to see when working with these different forms of encryption. And I'm going to... Hey, there we go. Alrighty. So now I want to try and make this a little bit more relevant to probably a lot of people here, though I don't think you can ever get away from encryption. So go through a little bit of tool support. So Snowflake supports either client-side encryption, so Snowflake will do it all yourself. So use your Snowflake, compute power to do that encryption, or it also supports server-side encryption. So push it to AWS to do. So that can be configured, either can be configured to decrypt files that are staged in S3 buckets before ingestion into Snowflake. And again, in terms of that, you get server-side S3 as well as server-side KMS. This one's an interesting one. So I've taken this from Fivetran. The way that it works is it generates its own data key, encrypts that source data with the data key, and then sends that data key to the secure credential service for encryption. You do have the option with Fivetran of using an external key provider. So in this case, it's either AWS KMS or you can go to Azure Key Vault. And so that way you can manage your own keys, keep them in the native service for your cloud provider, and kind of keep that control of those keys. Then Fivetran itself is running GCP, and it uses GCP's KMS to actually envelope on top of that envelope encryption. So if you choose not to use a custom KMS, then there's still going to be some envelope encryption going on. And then it returns the encrypted data key, or it could be a double encrypted data key to the Fivetran connector sync, and then encrypts that, encrypts the data to the storage bucket. So you can see these concepts are kind of applicable across all of the tooling, that people come across. I took this one from the HVR6 stocks. So HVR supports client or server-side encryption of files uploaded into S3 locations. So if you go to a location, you can configure, either that client or server side. It supports client side with master keys. So again, they're ones that you all manage yourself. Client side with KMS, so it'll actually integrate with KMS, do that management. So yeah, integrate with KMS to grab a key, and then do the encryption and decryption on the client side. Then it also has SSE S3 and SSE KMS as well support on S3. So I think that's time pretty much for me. Yes. Ash says I did pretty well on time. So
It's time for questions.
Time for questions. Have I bored everyone to death with talk about lots of encryption? Has anyone ever struggled with this before? Yes, I'm seeing one or two nods. Okay. Hopefully that helps a little bit with some of the core concepts. I know personally myself, when I came across envelope encryption and trying to work out what was actually going on and where the keys were going and what was happening, it wasn't so straightforward. So hopefully that helped a little bit. And thank you for your time. And enjoy the next presentation where we're doing demos and getting cool stuff going on. So.
Thanks, Alex, for making encryption so interesting.
That's a sell.
It's super important. Someone who worked at HBF for a while and APRA breathing down your neck, encryption is super important. Next up, we do have Wilson, as I said, who's doing DBT deployments end-to-end in Azure. 2 minutes if anyone wants to quickly go grab a beer or pizza.
Last time a trip with this kid.
Oh, yeah.
You do remember. It was that bad. Should be fine.
It doesn't matter what name it is.
Okay.
Yeah, join it up with my code, that's fine. Yeah.
But I'm here now, and my wife says, no, you have a choice. You're not getting on the market.
Right, yeah, good to go.
All right.
It's been very good days.
It is nice. Not so much on that.
And it's really
Good evening, everyone. How are we doing today? Good to go? Well, I can see some ears over there. Nice. How's everyone doing over there? All good to go? All right. So my name is Wilson Backward from the Virgin Insights, a new consulting company, but actually we're working heavily. Consulting company on the side is what right now we're using to pay the bills, if you know what I mean. But actually we're wanting to focus on developing software, right? We wanting to really strongly put Perth in the map of open source specifically. So we're working quite a few things, interesting things, I hope. And we're going to be releasing one of those in October. So it's going to be an open source solution for managing costs across various SaaS environment, right? So we've got a small group working on that. So that's what we do for now. And of course, consulting. So today is about Dvt and Microsoft Azure. By a show of hands, Dvt. Who knows about Dvt? Last time there were not that many people. Wow, that's a lot better. Last time was, I think, 2 or 3. So that's good. I think I saw like 10 hands. And what about Microsoft Azure? All right, even Alex, yeah. Good. Sorry, Alex, today is I'm talking about Microsoft Azure, so you know. All right, so what you guys gonna be seeing today is a solution, right? It's a working solution, end-to-end working solution on using Dvt on Microsoft Azure, right? And the key thing that I want to do, get right out of the way, is as of the announcement, one of the announcements I'm making today is as of today, we're making this solution open source. Essentially, you go there, you can do the QR thing, and you're gonna have access to the whole source code. It's quite a few hundreds of lines of code there, very interesting code there. I think you're gonna appreciate it. Alex, I think you're going to be able to use some of that code, hopefully. And yeah, it's all open source. Feel free to fork that or clone it and contribute to it. All right. So that's that. It's over there. MIT, classic MIT license. So that's that. So I'm starting with that also, so you know that you're going to be able to then after this presentation to go through the code and try to rationalize what I've been telling you. And perhaps trying to pick the good things, the bad things, and the lies. Hopefully, I'm not telling you too many lies today. But yes, it's going to be all there. So therefore, I'm going to do my best to try to use this time that we got, which is only 30 minutes, right, Jonathan? Only 30 minutes, to try to condense all of these into the key things. So I'm going to be focusing on the what the solution is doing, all right? Also, primarily on the why. Because a lot of people I can see they're going to be asking why, right? Why? What's happening here with this mixture of Dvt and Microsoft, and particularly around the architecture and the decisions that were made. And then finally, hopefully, at a high level, I can go through some of the code, do the demo for sure, and talk a little bit at a high level on the how. Okay. So let's start with the why, and I'm starting with the 2 key subjects. For today's presentation, and at the same time, there are the key constraints. So essentially what we're trying to do is implement a solution or a data platform that uses Dvt, but at the same time, we are restricted to Microsoft. And there are different reasons for that, all right? It could be political reasons, it could be, the the green light, the money green light in your company is only associated to Microsoft Azure. It's the path of least resistance. It's quite common, all right? It's quite common, so this could happen. And that is the constraint that we got, all right? Because definitely, when it comes to implementing data platform, there are at least, I don't know, literally hundreds of different ways of how we can do this, right? And nowadays, I don't know, GCP is getting quite strong and really good as well. So it's another realistic option. But today it's about Microsoft Azure and Dvt Core. That's all we got. That's where we got the money allocated. That's where we got the budget. Hopefully that's clear. And of course we got Dvt, but in this case we're focusing on Dvt Core because that's another thing. I'm gonna comment on that. That is, of course, Dvt Labs as a company has got Dvt Cloud. And one of the good things about Dvt Cloud is that it's gonna give you right out of the bat scheduler. And that is the number one thing that a lot of people here is going to be struggling with Dvt Core is where is my scheduler, right? So I got this thing in Jinja and Python, what have you. It's a bunch of static code that is sitting idle there. How do I run that? And funny enough, running things in a scheduled, repetitive manner, which is, robust, scalable, and stable, is actually not a simple problem to solve. Hence, we got Airflow, right, which was the pioneer on that. And then you got dedicated services across all over the place, batch services in Azure, in AWS, in GCP. And yes, it's not simple. So do not please underestimate the complexity that could go into having a robust scheduler. So that's the key challenge. Then in a humble way, we're going to try to solve with Dvt Core within Microsoft Azure, right? Because Microsoft Azure, unlike GCP, for instance, there are some elements in there that it lacks, right? Such as there is no Airflow. GCP has got Airflow Composer. Of course, we go manage Airflow from AWS. Fantastic. So that takes that problem out of the way. With Microsoft Azure, we don't have that equivalent. All right, so in terms of the high-level aspect of the solution, the number one thing that you're going to be finding in that repository, right, the GitHub repository that I gave you at the beginning, is more or less this, okay? So what you got right there in the middle is what I call the key circle of robustness or trust. That is, the whole solution is intended to be automated, tested, and CI/CD, all right? So that is a philosophy. It's not only a philosophy, it's also a must as part of the solution. So if we're implementing a solution, we need to make sure that we got the right quality elements in there so it actually works. So in the GitHub, you're going to see some reference, of course, to CI/CD. I'm going to walk through that so you guys can see it. And the automated testing bit is the bit that, I'm going to be honest, I removed from the open source because there is a lot of IP on the automation testing. The automated testing suite, to me, is where there is a lot of value there. But still, you're going to be able to use the rest, okay? So that's that, all right? And once again, I want to emphasize this because a lot of people here, we're all data engineers, and we know that the classic thing about garbage in, garbage out, right? Data in, that is garbage, data out is going to be equally bad, and insights on that data is going to be bad. Guess what? That analogy, that philosophy applies to everything that we do in life, really, and that doesn't exempt software. So if you are putting in bad lines of code, then the output of that is obviously it's not going to be good. So the whole repository is focused around automated testing and CI/CD, which is one of the things where we, in a humble way, want it to be really good at, all right? Automation and quality. So then on the left-hand side, what you see in there is infrastructure. So I'm just at a high level trying to pinpoint there the key things that we're going to be needing from an infrastructure perspective. So essentially, we're going to be using Terraform to realize this guy, just because Terraform is awesome. And yeah, and there are other options there, but seriously, Terraform is really good. And then what we're using is Terraform on Azure to create, well, what do we need? We need a data warehouse, okay? So in this case, the data warehouse happens to be, we are in Microsoft, so we're using Microsoft Synapse, Azure Synapse with data pools, all right? Dedicated data pools. That's a fancy name, and that's the data warehouse. And long story short, that is the classic SQL Server, MPP SQL Server implementation that has been there for many years, right? And now it's available in Azure. So that's the data warehouse. So yes, you will see the code Terraform implementing that from the get-go, right, from scratch. Of course, it's a component, right? And then you can make a decision of excluding that from your infrastructure because maybe you already got your data warehouse and you don't need to create a new one, but it's there. And also we're doing a bunch of credentials management, which is the second most complicated thing whenever you're doing anything, right? And we just got a really good presentation, fantastic presentation from Alex talking about security, encryption, all of that. Is by far the most complex subject, right? So yes, you're going to be seeing there how we leverage Azure Key Vault to handle all the credentials. And that's why I'm saying that this solution is enterprise ready, because everything is as you will expect it to be run from an enterprise. Then we got a storage. We're going to be needing storage, so classic blob storage from Azure, and of course the scheduler, which is the one that I was talking to you about from the beginning, right? That scheduler that we're going to be needing to orchestrate and run Dvt jobs. Last but not least, we're going to be needing a few images as in container images, because, well, we're going to be running a bunch of stuff using containers. On the other hand, the right-hand side, we got the data management component, and that data management side try to convey all the stuff related to what are the things at a high level that we need to be able to manage data, okay? So we're going to be needing, of course, data engineering. Mind you, right nowadays, people are making a distinction between data engineering and analytics engineering. And long story short, data engineers think of it as in loading, ingesting data, and doing your patterns and all of that. And analytics engineering will be more suitable related to your classic Dvt. Essentially, Dvt is expecting the data is already there, and you're just doing transformations, okay? So we're going to be focusing on analytics engineering, that is data transformation. And the ones that you see on the left, that is knowing the code. Mind you, it's there, it's required. These are critical components, but it's knowing the code, okay? And those the other two boxes there are equally important. So that's one for setting up your database. Imagine that you go a blank new database, okay? You go something like Synapse, or you go Redshift, or you go Snowflake. You're giving a blank canvas, right? So one of the first things that you need to do is set up your database, or set up your environment, or databases, whatever that is, right? Dev, test, UAT, and configure that so it's actually usable. And then on top of that, you need your security setup, which is equally complicated as well, and important. All right, so that's all the slides that I have for today. And now what we're going to be doing is jumping across to my browser. So this is the source code, all right? Open source, available to everyone to use, download and contribute. And I have already mentioned most of this. Let me just jump into this area, this picture, all right? So what you're going to be seeing soon enough is we're going to be having the way how the flows work, all right? So we're going to be having a developer using Dvt core. That Dvt core gets committed, and then we go multiple hooks, triggers happening there, either by PR or merge or which would have it, right? So something happens and then goes into a branch, and then that kicks off a CI/CD process. So what you're going to be seeing happening first is that we're going to be implementing our infrastructure. What infrastructure? The one that I described before, right? So data warehouse, key vault, all that stuff, right? Being created there. Specifically, I'm going to show you, it takes 20 minutes for all that thing to be set up, right? 20 minutes from start to finish. And I'm going to be honest with you, I was meant to have that infrastructure ready before the demo, and then I forgot to click the start button on Azure pipelines. But I was lucky enough to get it up in place. I think it's working, everything, hopefully. I'm praying a lot to the demo gods. But yes, that's how it's meant to work, right? Because the thing is, I didn't want to pay for money or for something that I'm not using, so I destroyed with Terraform, and now I reply just then. Hopefully it's all good. So then once we go to infrastructure, we're going to be needing our images. These are our specific Dvt images, nothing extraordinary happening there, but you're hopefully going to appreciate what's happening there. It's a classic Docker file, and you're going to be seeing some of the common configurations that you want to have in your Dvt images. Again, everything focused on the Microsoft side. And that little box there is database and security setup. So we're going to be bypassing that. We're going to be assuming that you already got a database set up, your schemas, and also your roles and your all security. All right, so for now, just let's bypass that. That could be a different conversation, presentation. And then the next one is your Dvt Transformations as well, right? So using Dvt to do transformations. So I do have that in there in the code. You're going to be able to see it, all right? So then in terms of, let me just go back here. Did I choose? Okay. All right, sorry, one. I'm just going to have to improvise a little bit because I lost all my tabs. Getting there. All right, we got the picture back. All right, so in terms of the pipelines, specifically, you're going to be seeing three pipelines, okay? So there is a Dvt run pipeline, which is a standard CI/CD pipeline that executes Dvt, all right? There is a Dvt core scheduling pipeline. So essentially what we're doing here is we're using Azure, what's the name? Azure DevOps pipelines, okay? And we're leveraging that. We're being a little bit naughty here because we're using essentially a CI/CD trigger to schedule Dvt to run, okay? Now, I have done this a few times, and I have to say that is a good starting point, but it's absolutely not scalable and not recommended at all, right? Soon enough, you're gonna be missing things like fallbacks, retries, multiple smarts that definitely you won't be able to get from a very standard basic scheduling such as the ones provided by a CI/CD tool, all right? But I'm putting that as an option because it's a good starting point, all right? You could try to do that for running things perhaps once per day, okay? But trust me, it gets absolutely out of hand, particularly if you're doing something like every 5 minutes. If one of the jobs fail, how do you recover? How do you trace back? How do you monitor those jobs? It's just impossible to do in CI/CD, all right? And then you're going to be having another set of CI/CD jobs. It's actually two, one for Terraform apply and the other one for Terraform destroy, okay? So what does the solution look like? How am I doing with time, Jonathan? Good. All right, so the solution looks something like this. On the one hand, on the left-hand side there, we got a set of resources that are common resources or shared resources. So we got a resource group, storage account, and the key vault where we store different credentials, right, for all the whole setup. And then on the right-hand side, perhaps you don't find this too confusing, but if you go to the top, you see here at the top, that's your data warehouse, right, being created. Essentially, you got Synapse, and you're going to be needing the data lake store, which is one of the storage where Synapse relies on. And then at the bottom, you see something interesting happening. This is where you guys, I really want you to pay attention to this bit, which is Dvt core scheduling type 2. So essentially with this solution, you are getting two types of scheduler, all right? Why is that? Because what we're trying to do here is compensate by the fact that we don't have a robust scheduler like Dagster, right? Or like Airflow available in Azure. And of course, a solution could be, well, you might be thinking, well, I could just deploy Airflow on Azure, right? Yes, that's one solution, assuming that you want to do the system administration or Airflow, right, on Azure. So that's the complexity there. So we're not wanting to go there. So we're just wanting to use the stuff that we got there just to get us going, all right? So there's, in this case, what we're doing, this scheduling type 2, what it's doing is using Azure Data Factory. And Azure Data Factory is kicking off through a set of jobs, all right? So by kicking off, I mean, you get Azure Data Factory, which is, think of it as kind of an ETL tool, has got multiple steps. And one of those steps is executing HTTP call. The HTTP call does the right authentication through Azure Identity, getting a token, and with that token, we use it then to kick off a set of jobs that are sitting on container instances and with Dvt core. So essentially, long story short, we got a image with Dvt. That image gets passed as a parameter a Dvt project, okay? And all that once it's put together, it gets triggered by Azure Data Factory. And through that Azure Data Factory, you do have a better access to better scheduling facilities because it's an ETL tool, right? So you can do things like, well, I want you to run every day, and if you fail, I want you to do this and that. So then essentially what we're trying to do is leveraging the scheduling facilities that we get out of the box from Azure Data Factory. If you're thinking about, well, Wilson, where do you get this from? Well, what's driving this architecture? To be honest, it's just the research, right? So the research that we did on what's possible with the constraints that we got available, this is what we saw a lot of people doing, right? This is not new from us. We tried to take the best from different people, sharing their experiences. And what you see here is pretty much what you're going to be finding if you do a ninja Googling on that. Pretty much is a summary of everything that we found. So essentially, one scheduling, long story short, one way to schedule Dvt is through Azure DevOps pipelines, and the other one is through Azure Data Factory, taking advantage of containers and container registry in Docker. Of course, there are other options. You could use Azure Functions, okay, and Cipher does as well. Every single different option will have its pros and cons. Here, I'm just showing you two. All right, so moving on. So I'm going to try to jump now into the code. And by the way, I got at the back of my head, how do I get back to those tabs that I lost? But should be able to come up with something. But going back to the code, this is what the code looks like. So the first thing that I wanted to show you is going right at the top here. You're going to be seeing Azure pipelines. Are you guys familiar with GitHub Actions? If you're familiar with GitHub Actions, look, it's not the greatest, it's not the worst, right? Like that's I guess the position probably of most people, right? Guess what? The engine for GitHub Actions is based on Azure DevOps pipelines. I didn't know that. I learned that. So yes, you're gonna be, if you like, if you used to use GitHub Actions, you're gonna be like at home using Azure DevOps pipelines. Okay, this is the same engine. It works exactly the same. You're gonna be putting a bunch of YAMLs, and in those YAMLs, the definition of the YAMLs is quite similar to GitHub Actions. All right. In this case, the YAMLs that we got is 4 in total, like I mentioned before. So there's one for Dvt create. So let me just go quickly through this. We are taking advantage, just like in GitHub Actions, of different templates. There is this clever person, I forgot his name, a lot of credits goes to him, who has got, of course, a template for setting up Python. So that's 3.7 there. And just very simple there, we go set up tools and wheels, updating those so we don't have issues with the installation of Dvt core, and then we install Dvt Synapse. So that is all the little ingredients to make all this working. Dvt Synapse, that's the adapter for the Synapse database, okay? So we install that with pip, nothing major happening there. I guess the only key thing to let you know there is, do you see that -Q quiet there? I have to add that because what was happening is there were issues when error and outputs were being formatted into the console. It's a recently known issue. You just go quiet and then you should be fine. The next bit there, which is equally important, is just the execution of Dvt. So essentially, you can see here that we're expecting to have a folder called Dvt project. In that folder, we're going to be creating a couple of variables. Those variables, we got some environment variables. Those environment variables are coming from Azure DevOps. I'm going to show you that in a sec. So everything is, the flow, like always, is starting, everything starts through your CI/CD and then goes all the way down, right? So the CI/CD, that's where you define your secrets, everything, and then goes all the way down. So these secrets have been defined in Azure DevOps, and then we do classic Dvt debug, and then devs and run. So that's your Dvt create. Schedule is exactly the same. Difference being is, like I said before, we're taking advantage of cron, right, for scheduling our jobs there. And again, I guess it's a good starting point, but definitely it's going to get out of hand very quickly. Hence the other scheduling type that we're using, okay? And last but not least is your Terraform create and destroy that you're definitely going to be needing to be able to deploy and destroy the solution. What all those infrastructure, all those resources get deployed through this. So I'm going to move on there. The next thing that I wanted to show you is the Dvt project. So this is a classic vanilla out-of-the-box project. You will see that there's not much happening there, other than we are creating a model. Okay, so we are definitely creating a model. So it's just very simple models there. Hello world. And these models are being executed. You will see those being executed. And we're going to be able to see those models and run a select statement on those models. Okay. Hopefully, I don't run out of time. And then, fairly quickly, there is, of course, the infrastructure folder, and a lot of things are happening here. Hopefully, I don't think I'm going to be having the time today to go through that. You do that on your own time. And any questions, just let me know. But essentially, that's where we're creating all the infrastructure, defining all the infrastructure to Terraform. And yes, I'm not kidding you. We got here Synapse. So yes, Synapse is being set up here as well. So going into the demo, I've got quite a few things to show you. Number one, let me see if we can access this fairly quickly. Azure DevOps, sign in. So the first thing that I want to show you is, again, we're starting the flow from the top. And the top in this case is my CI/CD tool, okay? So I'm gonna access my CI/CD tool, and what that's taking place, I'm going to go to the short console as well. And hopefully that should be enough to get me going. All right, so in terms of the Azure DevOps, is just a CI/CD tool. It's quite comprehensive. It used to be based on the old classic foundation server, Teams foundation server, TFS. And look, it's actually quite comprehensive. It's quite neat. And right now, there is a bunch of stuff there that I'm not using. The key thing that I'm using here is the pipelines bit, right, which is the CI/CD bit. And in here, you're going to see that I do have 4 different jobs. So there is the job for Dvt create, destroy, Terraform create, Terraform destroy, and Dvt schedule. Okay, this scheduling one is the one that you saw on the code just then that executes every 5 minutes. Okay. And if you see this, I was not lying to you, Terraform create, it was executed 50 minutes ago, right? If we got there, yeah, it was a bit risky. If we got there, you should be able to see all the stuff that happened there. It took, so started today at 5:57 p.m. and it took 18 minutes, all right? So a bunch of stuff happened there. You can go, well, you won't be able to see this, of course, but that's where all the Terraform classic stuff gets created, all right, infrastructure. So the next thing that I wanted to show you is those resources, right? Because this is the beginning of my flow. I'm creating, I've got my jobs. Just saw those jobs being defined here in the code, right? So those are these jobs here are being defined. Then Azure DevOps is going to execute those. And once those get executed, what I'm going to be getting is this bunch of resources. Mind you, this is one of our demo accounts, or I deliberately got it all clean. There's nothing in there. So everything that you see there was created 50 minutes ago, all right, 57 minutes ago, all of that. So if we do a quick review, we got a data factory, all right, we got container instances, we got a container registry, we do need to know to upload our containers. We got managed identities, give all storage account, Synapse, of course, and the dedicated SQL pool. This is your Synapse, okay? You might be wondering as well about Terraform state, okay? That's also a different conversation as well. Managing Terraform states can get very interesting, and it's also can be driven by the policies of your company, cyber, and the needs for backup, recovery, high availability. But here is it's probably the simplest implementation of it, which essentially we got a storage account, in that storage account, which is all encrypted. You put your Terraform state file there, nothing can read it. It's reasonably secure. It's going to be backup, and then you can always get it. All right. It is, to be honest, it's not too bad, but it's not the best. All right. I guess the best implementation will be the ones that Terraform Cloud offers for the state management. But yeah, that's how I'm doing in here. So we got a storage account, and that's where we store the state for Terraform. Now, if I go fairly quickly then into the next part of the demo, which is, where are you? Azure Data Factory. So I'm going to open Azure Data Factory. Think of it as kind of a ETL tool from the Microsoft Box. And then if I open this, then this is going to take us to something called Azure Data Factory Studio. All right? It's actually quite neat. In here, what we got is a few things happening. One of those being we have already set up a pipeline. This pipeline that is called literally Dvt execution. What it does is the execution of Dvt. So this is the pipeline that I was telling you. Hopefully you can remember this picture here. I told you that we are leveraging Azure Data Factory to execute. So we're leveraging Azure Data Factory to schedule and execute container, and that container has got an image with Dvt and the project Dvt, all the stuff that we want to run. Okay, so this is the pipeline that is doing that. So the pipeline gets defined. Let me show you very quickly over here. So if you go to Data Factory, you set up Data Factory from scratch, and the pipeline is just a nice, well, not nice, but it's a JSON, okay, definition. So essentially you can define that through the GUI, and there is an option for exporting. You go exporting from the GUI, don't do it manually. It's too hard. I try, no, it doesn't work like that. So do it through the GUI, try to export, and then just copy and paste, and it works like, like a dream. So that's what you see here is that pipeline. And by the way, you can also parameterize the stuff from here, all right? Because you do have access to it through Terraform. So this pipeline has been defined in the code, and then Terraform actually deployed the pipeline here. And then I should be able to choose a trigger now, and now I'm going to start playing all those demo gods, and then hopefully we see this thing running. And what's going to do is, if you see here, what it's doing is we're getting a service principal ID. If you guys are familiar with Azure identity, there are multiple flows on how you handle identity in Azure, like, I don't know, probably 20 different flows, depending on what you're using, and SAML, so on and so forth, the other one. In this case, we're doing one of the simplest one, which is I'm just getting the service principal ID, the service principal secret. This principal has got access to the containers, and also Azure Data Factory internally to Terraform has been authenticated or not authenticated. It is trusted by everything inside, so it's able to execute this, okay? That, of course, had to be configured. So once I get those principals, I'm using that secret, let's call it secret, right? To be able to get an access token or bearer token. So then I use that bearer token to then go and execute Dvt. So this guy here is the one that is doing the magic, all right? This run Dvt. So then this is where we need to start getting a little bit creative. So I'm running Dvt, but guess what? Think about it. We're running Dvt on a container, right? So anything could happen, or we don't know how long this thing is gonna take. Like literally, you're waiting. You're running a container is running something, now you're just waiting for that to do something. It might be a minute or an hour. So in this case, what we're doing is we choose sizing up, how long that might take, and just waiting for that container to finish. Once that container finishes, it's gonna exit. That exit is gonna give me signals, gonna let me know, look, I'm done. And then we just update the Dvt run status and end of story. So then if I go to the monitoring bit, this is the second time that I executed this. This is this execution happening with you guys live in progress. And this is the one that I did 6:17 just before I finished, right? So this here, I'm hoping, had run successfully, succeeded, and it had populated the synapse. So how do we know that? So if I go over here into Azure Data Factory, Azure Data Studio, it's actually another really nice tool. I wasn't really familiar with it, and now I really like it. It's a shame that I think it's only mostly compatible with Microsoft product, but otherwise it will be fantastic for using with any other database. It's really good. So then I just got my standard credentials, server, all that. If you're wondering where did I get this from, well, when you're using Terraform, defining all this programmatically, at the end you're gonna get some outputs. So what we're doing is we're getting those outputs, but we're not putting those outputs in the command line. We're putting actually those outputs back into Azure Data Key Vault. So then you can grab them from Key Vault. These values that you see there, that password and username, I already know them, right? Because in this case, it's not random. I already know them, so I just populated that. And now if I connect to that, this is the next bit where I am praying. All right, so then now we're connected to my Synapse instance. I'm going to expand that. And I got, this is the database. So if you're wondering about how Synapse works, it's an interesting way. Whenever you hear about dedicated pool, it's just a fancy name for a database. That's what dedicated pool is. It's just the database, okay? So this is my dedicated pool, a database. And then when you expand that, you're gonna see these tables. These tables were created by Dvt. This is my first Dvt model. If you go over here, and then let's just collapse that. If I go into Dvt project, models, my first model and my second Dvt model. So that's what you're going to be seeing here. Let me refresh that. There should be 2 of those, I believe. Select top 10. Maybe the other one is a view. Yeah, the second one is a view. So now I'm doing select top 10 on that, and let's wait for it. Now, the reason is, okay, it's working. How do I know also it's working, right? We're doing this live. Guys, I cannot stress this enough. All of these, there is a unit testing suite behind this, right? So hundreds of unit tests that I know that we're passing. So when I run this, I was trusting those unit tests, all right? Because I didn't change the code. So I cannot stress that enough. It's very important to keep an eye on those unit testing suite. So yes, that's now Synapse getting that back, and we know that we got to scheduling happening now. So one scheduling happening, just to wrap up, is the one happening to Azure Data Factory, where I can now just go into author and pipelines, and then a trigger, and then I can do a new edit, and then define my trigger there. So that's one scheduler, and the other scheduler is the one happening through the Azure DevOps pipelines. And as you can see, this guy here, in a very obstinate way, is running every 5 minutes. So if I click on there, we should have seen probably 3-5 executions, 6, 10, 15, 20, right? It's executing every 5 minutes and creating things. And if there was no database, it would have failed as well. I think that's pretty much all I got. How are we doing with time, Jonathan, for questions?
Yeah, good for questions.
All right, guys. Questions?
How do you get the run results and all those manifestos JSON files from the Azure container? Can you run the dbt run models?
Yes, good question. So the question is, how do we get all the run results manifests from specifically the container from Azure Data Factory? Really good question, and the answer to that is here. It's one of the difficult bits, and I'm going to be honest to you, probably it's not the close. It's something that could be enhanced, right? So if you got in here, essentially what we're doing is we are sleeping, all right? So we're sleeping in a fixed manner, waiting for this to work to finish. But in this case, I know that my execution won't take more than 5 minutes. That's what we're doing there. There are some options where you could, mind you, we are not doing it here, but trying to answer your question, give you some guidance, hopefully a good one, is those outputs are going to be available in the container, all right? And then you will have to have, I'm going to show you, by the way, at least a suggestion, you're going to have a centralized login mechanism. To send that there, it's not here. You need that centralized login mechanism to be able to do what you wanted to do there, okay? Hopefully that helps a little bit.
Yeah.
And on that note, just very quickly before, if there is one more question, happy to take it, but I want to show you something very quick. Thanks for the question. It was really good and just prompted a thought. Is the additional enhancements. If you go here, there you go, mate. Sending all logs to centralized logging repositories such as your manager, all right? It's reasonably simple, but it will help a lot. Another one is dynamic extraction of short key vaults values from all automation scripts. And yes, you will see some of the considerations there, but hopefully those additional enhancements will help a little bit. Any other questions?
I guess is there a synchronous way to call the container and sort of not do a sleep, but rather execute the task and wait, like the task itself is going to kind of wait in Data Factory until Dvt is complete, rather than have to wait in Data Factory.
So you wonder if there is a way to wait for it programmatically as opposed to wait? More say event-driven as opposed to waiting for it?
Yeah, kind of more like Data Factory at the moment. You trigger a web API call, it starts the container instance, but that's asynchronous. You kind of let it fly, and then you have to wait in Data Factory for 5 minutes, and you check the results after. Is there a way to call container synchronously?
Yes, okay, yeah, so do I need to repeat the question or is audible there? I think it's...
Actually, it is audible, yeah.
All right, so the question was, is there a way to Azure Data Factory how we can get the status from container? Similar to the previous one, slightly different, but it's how I can get that visibility in a synchronous manner. What's happening there, Jonathan, is when you run the container, is a fully asynchronous activity. So you run that thing, right? The container is doing something, and that something is not responsibility of Azure Data Factory. It's just simply a trigger, right? So then containers, one of the number one things that's going to happen is that container is going to randomly disappear. And I'm using random word because if an error happens 5 seconds into the execution, it will choose error out and then kill the container, all right? Another way how the container is going to finish is actually the execution goes well, but it took 5 minutes and then kill the container. Or it could take run the execution, but in this case, it's taking 1 hour and kill the container. So when that container killing happening is very random, right? So that's why probably something through the monitoring, centralized monitoring solution, where essentially what you're doing is just waiting for that final log message telling you, look, I'm done. Right, so essentially just monitoring on the events coming from a centralized login message is the way that perhaps makes more sense. But also on that note, when you start thinking about this, right, guys, also it makes you wonder, well, how far do I need to go to be able to do all this with Dvt in Microsoft Azure, right? How much is how much, right? At some point you're gonna be preferring just, I might as well buy the bullet and perhaps just get Airflow working or Daxter working. I think Daxter is a lot simpler than Airflow from a system admin perspective. But that's the thing, finding that balance between how much customization I really want to do because I want to use Dvt on Microsoft Azure. Hopefully that makes sense. Yes, question?
Have you used the Astro on the Azure platform, which is the managed Airflow in the Azure?
No. I look it up, and probably, hopefully, I didn't do my homework really badly. But look it up. As far as I understand, only GCP and AWS have Airflow, and all the references that I saw for Airflow and Azure were just blueprints to have it set up fully. So it's kind of a blueprint, but then the system admin is on you. So that's what I was trying to avoid. But I don't know if that's what you're referring to.
I think recently the Astronomer, the company which is showcasing that Astro as a product, so you can run it on the Azure or AWS, which is the Airflow scalable solution, which could be available. Because there were some drawbacks from the managed service in the AWS for Apache Airflow.
Okay. All right, just to repeat that really quickly because it's important. So Astronomer, the company that defaults behind Airflow, I think it seems like they're doing some kind of partnership with Microsoft, which makes sense perhaps in starting to push the product over to the environment. And again, it comes down to as well if you can use Astronomer through Azure, right? Which I'm guessing is going to be through the marketplace or something slightly different as well. So yes, I think probably took enough of everyone's time. Thanks for everyone's time. Good night. Thank you.
That's it. Hello. That's it. Thanks everyone for coming. Please feel free to finish off the rest of the pizza and drinks. And thanks for coming, Wilson, presenting, and Alex as well, if he's still here. He's still here. Thanks everyone.